Okay, here we are. All right, by substitution and elimination. So today we're going to basically do a week and a half of Algebra 1 in the next 34 minutes. Okay, and then tomorrow we get to add in solving systems of 3 equations with 3 variables. It's going to be really fun. Okay, we all got the title down. We ready to start? Okay, substitute. While you're copying down that system, what's the job of a substitute?
To take the teacher's place.
To take the teacher's place. And they're supposed to do everything the teacher does, right?
Yes, ma'am.
Yes, and that happens 10 out of 10 times.
You want us to write that?
Yeah. What's on the screen? Yes.
Oh.
Yes. Okay, so if the teacher's out sick, the substitute takes the teacher's place. All right, I like that analogy. Let's work with that as we go through this. So if we want to solve this, meaning we want to figure out the x and y that make both equations true, the point where these lines meet, can we all agree that we could graph these? They wouldn't necessarily be very fun, like the second one wouldn't be very fun to graph, but we could. Okay? So without a graph, we're going to do that. Substitution means we are going to look for one variable, x or y, in one of these equations that we can easily get by itself. Easily get by itself. So do you see one variable in one equation that could easily be gotten by itself? There's one that should be standing out to you. Yes?
On the top one, can you be a y by itself?
Okay, and that's a good point. We could get anything by itself. But there's one that's going to be easiest. On the top one, what if we got x by itself? And I say that because it doesn't have a coefficient, right? All these have a coefficient, so I would have to divide by something to get it. But what about x, right? So it's not by itself, and when I say by itself, I mean it's the only thing on its own side of the equal sign. So with it is this plus 2y, right? So if I want to get rid of this 2y, I would have to subtract it, right? And it would show up on the other side as a negative 2y, right? Okay, so this is going to be, I can rewrite this as x equals negative 2y plus 4. Okay, so all I'm doing is getting one variable by itself. All right, now look, x is the teacher who's sick today. And negative 2y plus 4 is the teacher's substitute. So it's going to go in the place of x, the teacher, in the other equation. So I go to the other equation, and when I see x is sick, in for x today is negative 2y plus 4. Okay? Does that make sense? So what does that look like? So now we go and we rewrite the second equation. So I'm going to start with 3. But instead of 3 times x, it'll be 3 times the substitute, which is negative 2y plus 4. And I have to put the substitute in parentheses because it's the entire expression. And then I keep going. Minus 4y equals 7. Okay? Does that make sense, what we just did there? All I did was rewrite the second one with a substitute in it. All right, now you want to check. This equation right here should have only one type of variable. And I'm writing that in words because that's important. If you have x's and y's in this equation, then you did something wrong. It should only have y's. Do you know why? Like, why do we need only one variable, one kind of variable? Because we substituted, yeah. And we can solve that. It's impossible if I say x plus 2y equals 4. What's x and y? Like, it's hard. You can't solve an equation. I mean, you can guess and check, right? I get that. But you can't solve an equation with 2 variables. It only has to be 1. All right, now we use our algebra skills. Okay, so we're going to distribute the 3. Now we're going to solve for y. So we got to do all that algebra business. So we distribute the 3. 3 times negative 2y is negative 6y, right? 3 times 4 is 12. Minus 4y equals 7. Right? So far, so good? Okay, now what can I do? Combine like terms. I have y's. I have negative 6y and negative 4y, which makes negative 10y. Plus 12 equals 7. Well, don't forget. Sorry about that. All right. Minus 12, right? You always undo the addition, subtraction before you undo the multiplication division. So I'm minus 12, negative 10y equals 7 minus 12. Put that in your calculator if you don't know what that is. Anyone know what that is in their head? 7 minus 12? Negative 5. Now, I want to get y, so I divide by negative 10. Divide by negative 10. So I'm looking at y is equal to negative over negative cancels. 5 over 10 is a fraction. Excuse me, which reduces to 1/2. Right? Okay. All right, we got y. But remember, there were two variables here, right? We need x. So now we take this y that we have and we plug into an equation. I'm abbreviating equation with EQ to get x. Okay? So I'm going to take that answer for y, plug it into any equation that I started with, and I'll get x. Okay. When you do that, you have a choice. Sorry, I'm going to scroll down in just a second. I'm just putting it up here for a minute. I have a choice. I can plug it into the top equation, or the bottom, or the one that has my substitute as it, right? Math will always be easier if you pick this one. Okay? So let's plug that in. So x equals negative 2y plus 4. So x equals negative 2y plus 4. So now I'm going to plug in 1/2 for the y. So x equals negative 2 times 1/2 plus 4. All right, negative 2 times 1/2. You can use your calculator, or just think, what's 2 halves? 1, right? So it'd be negative 1 plus 4. What's negative 1 plus 4? Anybody? 3. Okay. This is 3. Okay. Now you have your x, and you have your y. You have a solution to the system. So, only thing left to do is throw it in your solution set and call it done. X comma y. Remember, x in an ordered pair, x always comes first, y comes second. What can we check it to see if we were correct? Plug it back in the equation, and you can kind of do this mentally, right? All right, 3 for x, 1/2 for y. Let's just check. 3 plus 2 times 1/2 is 1. Is 3 plus 1 4? Yes. Yep. 3 times 3 is 9, minus 4 times 1/2. 1/2 of 4 is 2. 9 minus 2 is 7. So it works. Also, if I were to make graphs, right, lines, graph them, all that good stuff, they would cross at that point. Which would be kind of ugly because we never really graphed them where the solution was that weird point, right? Okay. All right, we good with this one so far? What questions can I answer about where I got anything? Excuse me. Nothing? All right, let's try another one. Give you a second to copy that one down. Solve by substitution. Okay, if we're doing substitution, we got to be looking at our equation thinking, all right, what variable in any equation looks easy to get by itself? What do we think? X or Y? X, right? First equation or second? First. Because the second one has a negative in front of it, right? So a little bit more involved there. So I'm going to pick the first x to get by itself. And to do that, this 3y is going to go on the other side. So it's going to be x equals negative 3y plus 18. And that stuff, the negative 3y plus 18, that is the substitute. That goes in the place of x in the other equation. So always remember, the substitute is going to go in the other equation, the one you didn't move around. Okay? All right, and then you just write the second equation down. But when you get to x, remember, it's out for the day. You need to use its substitute. So I write 2y. What do I write next? I write a minus sign next, and then whatever x is, which is negative 3y plus 18. And then I continue writing the rest of the equation, equals 7. Okay? Check, do I have only one type of variable in that equation? Yes, so we're good. Okay, now I simplify. Now remember, these parentheses are so important because they show that I'm subtracting this whole thing. So think about this. 2y minus negative 3. What do you know about minus negative? It's positive, right? So minus negative 3y is really going to be plus 3y. And I'm going to have minus 18. So that's just going to be literally minus 18, right? Equals 7. Okay, from here, can you solve for y yourself and then plug in to get x? Think we can do that? Let's try it. Take a couple minutes to do that. I'll walk around and tell you if you're right, okay? You got the algebra part now. Yeah. Right, it's essentially eliminating. You can leave it as distributing the negative sign. That's why it's minus, or you make it minus positive 18, which is fine. chance to see you for the full answer. If you got this, you were right. If you didn't, let's go through that. 35 is the right answer. So you can combine these because these are both y's, right? That's the whole point of substitution, so you have only one type of variable. So 5y minus 18 equals 7. Then you add 18, not subtract 18, you add because that's what makes it 0. That makes it go away, right? So 5y equals 25. And then we divide by 5. Y is 5. Plug that in to get x. You can choose any equation to plug in. I would pick the substitute one. So x would equal negative 3y plus 18, or no, is it? Yeah. So I'm plugging in 5 for y. Negative 3 times 5 plus 18. So negative 15 plus 18. So x is 3. Hence, this is your solution right here. Okay, you good? So we're going to leave substitution for a minute. Okay? All right. People typically like this one better. Elimination. Now remember this? This is when you add equations and something goes away. Remember that? Well, it happened. Okay. This is the same problem as the first one we did. So we know the answer to this already. Should be 3 1/2, right? We're just going to use a different method to get there, okay? All right, as you're copying this down, elimination is a good option if you're presented with a system that is stacked like this. Standard form, with x's on top of each other, y's on top of each other, right? And what you want to do is add these together and have one of those variables form a 0 pair and just disappear. Like, what's a 0 pair? What are two numbers that make a 0 pair? Let's make sure we understand that concept. 2. What makes a 0 pair with the number 2? Negative 2. What about negative 20? What makes a 0 pair with that? 20. It's positive and negative of the same number, right? Okay, and I don't have that here, right? I don't have that here. In Algebra 1, they start you off already set up. So what we have to do is we have to choose one variable to create a 0 pair with. If I choose to do that with x, what would these numbers have to be? Positive and negative what? 3. And that one's already a 3. The top one would have to be multiplied by negative 3. And then I have negative 3 and 3. Okay? I could do that. If I choose to have y be eliminated, what could I make these numbers up to be? Positive and negative what? Can I turn one of these into the other? Can I turn 2 into 4? Yeah. 2 times what makes 4? 2 times 2 makes 4. So if I multiply this by 2, wouldn't that make a 0 pair? Yes? Are you with me? Okay, so we have to decide which one we want to do. We won't be wrong. We just have to make a decision. So do we want to eliminate x or y?
X.
X? Y?
X.
Here's how I make my decision. You can't be wrong, by the way. I make my decision based on what's the smaller number. I'm going to multiply by negative 3 if I want to eliminate x. I'd be multiplying by 2 if I want to eliminate y. I look at it and go 2 smaller, I'm going to eliminate y. So I would but you can do it this way. All right, so I would have to take the entire equation and multiply it by 2. Even though I only want that 2y to be multiplied by 2, for this to be a legal move, I have to multiply the whole equation by 2. So let's see what that gives us now. So I'm going to rewrite that. That has now turned into not x, but 2x, not 2y, but 4y equals 8. And I'm not going to change the bottom one because I will have my 0 pair that way. So this is going to be 3x minus 4y equals 7. You see how we have that 0 pair? Now we're going to add equations together. So we're going to add these together. And this is like 4th grade addition, right? You know, your big long equal sign, you add vertically. So 2x and 3x 5x. 4y and negative 4y, 0 pair, there's nothing there, equals 8 plus 7 is 15. Now, didn't that simplify really quickly for us? Yes. Isn't that a quick equation? Solve for x. Divide by 5. X equals what? 3. Great. We have x. The rest of this process is just like substitution. We plug this in to any of our equations to get y. When you go to choose, I always pick the one with the smaller numbers. So maybe I'm going to pick this top equation. So now I'm going to plug this in to get y. Plug in to get y. So I'm going to choose the original top one just because it's got the smallest numbers, right? X is the number 3 plus 2y equals 4. And now I'm solving for y, right? Wouldn't I just take away 3? So 2y equals 4 minus 3 is 1. Then I would divide by 2. Well, we already did this problem, right? Y should be a half, right? There it is, 1/2. So our solution would be the point 3 1/2. Okay? So with this method, it simplifies pretty quickly, but there's a lot of choice involved, a lot of decisions you have to make. And there's a lot of different ways you can do this problem. Okay? Okay, questions about this one? All right, let's do another one like it, but in this next example, we're going to have to multiply both equations. Okay? So here's the next one. There it is. Go ahead and write it down. And as you're copying it down, be thinking of which variable we want to eliminate. Are we going to eliminate x or y? Okay, what do we think? X. Okay, let's think about this. We need a 0 pair, right? If we choose to eliminate x, what could we make these coefficients become through multiplication that would be the same number? 6. And if you're like, how did we get 6? Here's your strategy. Multiply them together, it'll always work. 3 times 2 is 6, right? All right. And now we just have to make one of them negative, right? If I wanted to eliminate y, what would I have to make them? 15. So you just ask yourself, do I want to work with 6 or 15? 6 is smaller, right? Okay. So let's eliminate the x. So to make this one a 6, we have to multiply this by what? 2 or negative 2. It doesn't matter. One of them is going to have to be negative. You're just going to decide which one you want. We'll just do that with 2. And then this one would have to be multiplied by negative 3. Why negative? Because I need one of them to be a negative 6 so that they make a 0 pair, right? Okay. Now, where people mess up is in this step right here. They don't multiply everything in the equation. You have to multiply everything. So our top one will turn into 6x plus 10y, right, equals 2 times negative 16 is negative 32, right? And our second equation, now multiplying everything by negative 3. So negative 3 times 2x is negative 6x minus 9y, right? Because negative 3 times 3 is negative 9. Equals, what's that number going to equal? What's that going to equal on this? Positive 27, because negative 3 times negative 9 is positive 27. Now we add them together, because now we have our 0 pair, right? Okay. X's cancel. 10 plus negative 9 is really like 10 minus 9, which is 1y. equals negative 32 plus 27, negative 5. Okay, well that one simplified really quickly, right? There's y. Now we plug in to get x. And you've got 4 equations you can choose from. You just got to pick one. Pick the smallest number one, which I don't know what to put. Second equation? We'll just pick that one. So I'm going to copy this down, plugging in the number negative 5 in the place of y. So 2x plus 3 times negative 5 equals negative 9. So 2x, 3 times negative 5 is negative 15 equals negative 9. Now we add our 15, right? So 2x equals negative 9 plus 15 is 6. Divide by 2. X equals 3. So our solution is the 0.3, negative 5. Okay. What questions can I answer about this one? Seems like the hardest part about these kind of problems is this. Knowing what to multiply by. You're never going to be wrong. Honestly, if you just want to, if you take thinking out of it, you're never going to be wrong if you just go, all right, I want to eliminate x, multiply them by each other, and make one negative. You'll never be wrong if you do that. Doesn't mean that's the easiest way, but it will always work. Okay. All right, we got one more. Let's do it, burgers and shakes. Sword problem. Okay. You don't have to copy this down word for word in your notes. Maybe just start at the system with me, okay? But let's read it and understand what's going on, okay? 4 large cheeseburgers and 2 chocolate shakes cost a total of $7.90. 2 shakes cost 15 cents more than 1 cheeseburger. What is the cost of a cheeseburger and a shake? Okay. Did they tell us what variables to use? No. Someone has to. Either us or them, right? And they didn't do it, so it's up to us. So we got to go to what we're trying to find. We're trying to find cost of a cheeseburger. What do we want to use for that? What letter? C? Okay. So I'm going to say C is going to equal the cost of, I'm just going to say burger. I don't want to write it all out, okay? And then how about S for cost of the shake? Of a shake. Okay. Now we go through and we write our system. 4 large cheeseburgers and 2 chocolate shakes. So 4S, right? 4C, because 4 times whatever a cheeseburger costs, we don't know what it is, but whatever it is, plus 2 times whatever a shake costs is going to total up to be $7.90. By the way, in an equation, you don't use the dollar symbol, okay? You add it in there when you say your answer, but when we're doing the math, you drop it. Okay. Next equation. 2 shakes, so that would be 2S, right? Cost 15 cents more than 1 cheeseburger. So 2S equals 1 cheeseburger plus what? 15 cents. So 0.15. There's our system. You could have put 0.15 plus C. It's the same. Okay? All right, now the question becomes, what method are we going to use to solve this? Are we going to use substitution or elimination? Use substitution. Both would work. If you were to use elimination, you'd have to rewrite this so we were stacked, right? Elimination was you're stacked up, and we're not. But look, they tell us that 2S is this. Well, don't I have a 2S up here? So can I just plug this in? Yeah. I don't have to divide by 2 to get S by itself because I'd just be multiplying by 2 right up here. Alright, so let's see what that is. 4C plus its substitute, which is C plus 0.15, equals 790, right? Now we just solve it. 4C plus C, 5C, plus 0.15 equals 790. See how much these cheeseburgers cost, okay? There was nothing to distribute. If you're wondering why I didn't distribute anything, it's because there's nothing to distribute, right? Okay, take out the 15 cents. If we take out the 15 cents, what do we got left? 5C equals 775. That's 775, right? Isn't 790 minus 15 cents, 775? Yeah. And now divide by 5. Because 5 cheeseburgers is 775. So what's one cheeseburger? Someone with a calculator? 155. It's a deal, right? I don't even know what a cheeseburger costs at McDonald's these days. Okay. Now plug it in and get a shake, right? 2 shakes equals whatever a cheeseburger is, which we now know is 155, plus 15 cents. I'm just plugging into this equation. So 2S would equal 170. But that's what 2 shakes are, so divide by 2. 1 shake equals $1.70 divided by 2 would be 85 cents. Okay? Pretty good deal, right? Okay. I can't leave my answer like this. And it doesn't make much sense to put it in an ordered pair because this isn't a line. This is food we're talking about, right? So when you answer this, you just answer the way it was presented. So a cheeseburger costs, now we can add the dollar signs. Now that we're stating our solution, we can add the dollar signs. And the shake would be 85 cents. Okay? Make sense? Okay. All right. What is your homework? The odds of worksheet 6. Now, you didn't pick up yours because I ran out of copies. I am getting them as soon as the bell rings. I'm walking over and getting some. You can get them on your way to the bus, or it's already on Google Classroom. Everybody can get it there. Well, odds are not a grade, right? Well, look, if you don't do the odds and you don't check yourself, how are you going to know if you learned this really? Because everybody thinks they got it when they're in class watching the teacher do it, right? It's only when you actually try yourself that you figure out if you learned it or not. Okay? I'm going to ask you when you get in tomorrow what questions you have. So if you have questions, make sure you ask them.
Can you do my test tomorrow during class?